Okay. Hi guys, this is video 2-12 on page 21 in your video packet, and this one is to be watched Monday 10/17. And the homework that corresponds to this video is going to be page 19, just numbers 1 and 2. Okay, so today we're learning something called the chain rule. And you want to use the chain rule whenever you're going to take the derivative of a composition of functions. So this is what the chain rule is. If I have a function, f of g of x, so a composition of functions, and I want to take its derivative, what I do is I take the derivative of the inside function, which in this case is g, so g prime of x, and then I multiply it by the derivative of the outside function, so f prime of blank, but with g, the original g of x, plugged back in. Okay, and I have a really nice method of doing this, and so I think it's going to be pretty simple, pretty straightforward. So here we go, guys. Oh, never mind. Okay, so use the chain rule to differentiate the functions below. So here's example 1. Now, eventually you're not going to have to do this, but when we start, as soon as as soon as you realize that you're going to be using the chain rule, I'd like you to put a little chart inside, outside. Okay, so we're going to figure out what is the inside function, what is the outside function. Now, to find the inside function, we practiced this yesterday, look inside parentheses, look under radicals, okay, things like that. So I see x squared plus 5x is inside of parentheses, so I'm going to let that be my inside function. Well, what function is it inside of? It's inside of blank to the 7th, okay? And now, to use the chain rule, I just have to take the derivative of the inside function, multiply that by the derivative of the outside function, but with the inside function plugged back in. Okay, so I'll show you how to do this. So the derivative of the inside function is 2x plus 5, all right, times the derivative of the outside function. Imagine, guys, that this was x to the 7th. You could use the power rule on it. So I'm going to use the power rule on this, except with the blank instead of the x. So I end up with 7 blank to the 7 minus 1 is 6. And then the original function that was inside has to go back in there. So x squared plus 5x. Okay? So there's that, guys. You don't really need to simplify anything, but I'm going to move this constant out front. So my final answer, I'll have f prime of x equals 7, 2x plus 5 times x squared. Oh, sorry for the shadow. X squared plus 5x to the 6th. Okay, so that's the final answer. It's just convention to put coefficients out in front, so that's why I'm doing that. But you could have left it like that and it would have been fine. Okay, example 2. Oh, I feel like the lighting is not good. Okay, example 2. So you know that you're going to use chain rule whenever you have like one function inside of another function. And I look here and I see 2 minus x to the 5th. That's a function on its own, and it's inside of a radical. And the radical has a coefficient of -3. So when I do my chart here, so my inside-outside chart, I have 2 minus x to the 5th, and that is inside of -3 radical blank. So I'm going to go -3 blank to the 1/2. Very often, guys, the outside function is going to be something that you can use power rule on. So I'm just writing it like this so that I can clearly see what the exponent is and all of that stuff. So derivative of the inside function is -5x to the 4th. All right, and you could put parentheses around that if you want. You don't have to, though. And then the derivative of the outside function, I'm just going to use power rule. It's -3 times a half, so -3 halves, blank to the 1/2 minus 1. So 1/2 minus 2 halves is -1/2. Okay. And then what goes back in? Remember, it's the original inside function goes back in. So 2 minus x to the 5th. All right. Now I'm just going to write this so that it looks a little bit prettier. I'm going to gather these, I'm going to multiply both of these coefficients, and I'll have them out front. But again, you could leave it like that if you wanted to. So I have f prime of x equals, I end up with positive 15 over 2 x to the 4th times 2 minus x to the 5th to the negative 1/2. Okay, so there's that derivative. One more. Okay, so this is example number 3. I see a function that looks like it's inside of another. I have x squared minus 9x that's underneath a radical. So I'm going to do my inside-outside chart. Kids, in my previous students called this the in and out chart, so you can call it that too if you want. And so in the inside function is x squared minus 9x. The outside function is the 5th root of blank to the 3rd. So I'm going to go right ahead and convert this to from radical notation to exponent or exponential notation. So this is to the 3/5. Okay, so the composition works like this is the input of that. Okay, so now I can go derivative of the inside, derivative of the outside. The derivative of the inside function is 2x minus 9. There I do need parentheses because it's a binomial. And then power rule on this, 3/5 comes out to the front, blank to the 3/5 minus 1. 3/5 minus 5/5 is negative 2/5. Okay? And so I have f prime of x equals 3/5, because that's a coefficient, so I like to put it out front. It looks like an 8. 3/5 2x minus 9 times, oh, this has to go back in, remember, so x squared minus 9x times x squared minus 9x to the negative 2/5. Okay, guys, there's that. So homework is for you just to try 2 of these. Let me reiterate. Page 19, numbers 1 and 2. Okay, see you soon.